For the introduction, logical implication and rule of inference help us decide whether a logical argument is valid. A logical argument consists of two parts, premise and a conclusion. The premise argues a statement, while the conclusion is the statement to be proven. To analyze an argument, each statement is written using logical symbols. This makes the argument clear and easier to study. We then examine how the conclusion follows from the premise. An argument is valid if the conclusion is true whenever all the premises are true. Truth tables are used to test all possible cases and check the validity of the argument. A logical argument has two main parts, premise and the conclusion. Premise are the statement we start with. The conclusion is what we are trying to prove. When we say if P then Q, we are expressing a logical implication. This can be written formally as P1 and P2 and P3 and Pn if then Q. This means if all the premises are true, then the conclusion must also be true. The idea of implication can be expressed in many different ways. For example, if P then Q, Q if P, P is sufficient for Q, Q whenever P. All of this means the same thing logically. Remember, P implies Q means that if P is true, Q must also be true. Two important logical equivalents help us work with implication, which is contrapositive and implication. These equivalents are powerful tools when proving or simplifying logical statements. So next is we have an example of truth table, which is we have two logical variables, P and Q, the expression we are testing. When we look at the last column, which is the result of the entire implication, in all four possible cases, the value is true. So when a logical expression is true in all cases, we call it a tautology. A tautology means the argument is always valid, regardless of the true value of P and Q. Now, let's see how this works in real-life argument. So, if the strawberry is red, then it is sweet. The strawberry is not sweet. Therefore, the strawberry is not red. So, using notation P, the strawberry is red. Q, it is sweet. The argument form is P if then Q, not Q, equal to not P. For learning objective, the first one is to explain the concept of logical implication and rule of reference. Second is to identify premise and conclusion in logical argument. The third one is to translate verbal statement into logical symbol. And the last one is to verify logical implication using truth table.
So today I will teach you logical implication. If you answer my lecture today, you will understand this topic.
I attend the lecture today. Then you will understand the topic. Naturally, if you study carefully, you will pass the exam.
If you pass the exam, you will graduate.
So if I study consistently, I will graduate.
Yay! If you guys submit assignment, you will get marks. Now she did not get any marks, then she did not submit the assignment.
I complete the assignment
And I studied for the test.
So when she complete the assignment and cannot study.
Now she attend my lecture and complete the assignment. Therefore, now she attend the lecture.
So yeah, I passed the exam.
Then you pass the exam or human authority.
This part for example 1. The question is construct a truth table to determine whether not P or Q and P and Q and P logically implies to P and Q. First step, we should write not P or Q and P and Q implies to P and Q. We will doing truth table. First column P, it is going to be true, true, false, false. Next, second column Q, the true values is a true, false, true, false. In third column is not P, where we should negate the true value from column P, it will be false, false, true, true. Then for the next column is to find not P or Q. When it is this tension, this statement is true when one of the statement is true. The true value is true, false, true, true. Then column 5 is to find P and Q. When it is conjunction, this statement is true when both statement is true. The value is true, false, false, false. And then we want to find the value of P and Q. This statement is true only when P is true and P and Q is true. The true value is a true, false, false, false. The next column is we combine both parts of the antecedent, not P or Q, and P and Q. This is true only when both components are true. The true value is true, false, false, false. The last column, we evaluate the implication, not P or Q, and P and Q implies to P and Q. It is true, 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 true. Therefore, for the conclusion is not P or Q, and P and Q implies to P and Q is tautology. Then the argument is valid.
Another example 2 is Alia will go shopping if and only if she does well in her exams. If Alia goes shopping, then she will be camping near the lake. Alia goes for a picnic or she does not camp near the lake. Alia does not go for a picnic. So for the first question is declare the four primitive statement using the symbols P, Q, R, and S. Let P is Alia goes shopping, Q is Alia does well in her exams, R is Alia will be camping near the lake, and lastly S, Alia goes for a picnic. Next question is write all the premise using the symbols. P implies Q and Q implies P for premise 1, P implies R for premise 2, S or not R for premise 3, and lastly not S for premise 4. The last question, we determine the conclusion using rules of inference. From premise 1, P if and only if Q becomes P implies Q and Q implies P using the biconditional rule. From this, we take Q implies P using rule conjunctive simplification. Using Q implies P and P implies R, we get Q implies R by syllogism. From S or not R and not S, we conclude not R using disjunctive syllogism. Finally, from Q implies R and not R, we conclude not Q using modus ponens. So, the conclusion is Alia did not do well in her exam.
Example 3, the question is if it is rain, then the ground will be wet. The ground is wet if and only if the plants grow. It is rain. If the plants grow, then the gardener will be happy. Therefore, the gardener will be happy. Now, we define the primitive statement. Let P be its rain. Let Q be the ground will be wet. Let R be the plants grow. Let S be the gardener will be happy. Next, we write all the premises using symbol. P implies Q for premise 1, Q by conditional R for premise 2, premise 3 is P, premise 4 is R implied S, so the conclusion is S. Next, I will prove the validity of the argument using the rule of inference. First, list all the given premise. Next, we start the inference step. From premise 1 and premise 3, we use modern ponens and we'll get Q. Then from premise 2, the biconditional can be written as Q implies R and R implies Q using the biconditional rule. From this conjunction, we choose Q implies R by using the rule of conjunctive. Next, using Q implies R and R implies S, we apply syllogism to obtain Q implies S. Since we already have Q and Q implies S, we should apply modus ponens again and conclude S. Therefore, the conclusion, which is the gardener will be happy, is logically valid.
In conclusion, logical implication allow us to derive a conclusion from one or more given premise in a logical valid way. To verify this, we use rules of inference or truth table. This is important because complex systems must be analyzed and tested to ensure the process flow is efficient and generates the desired result. By doing this, we can transform complex logical statements into simpler, more manageable form.
Tapping on your window right before you